The main focus of this lecture will be in controlling when and how some parts of our code are executed. So we're going to look at relational operators by which we can compare different values. The Boolean values true and false, which we can obtain when we do these comparisons. And then we're going to look at the if statement, which allows us to place blocks of code under some condition, so that they are only executed if the condition is true. We're also going to look at namespaces, how Python organizes the names referring to different objects, and how we can import objects from other modules. A Python module is one file where we store our source code, and you have libraries installed with different modules which have useful functions and classes that you can use by importing those into your own code. And then we'll bring that together and use it with an example where we're going to access remote resources on the internet. So we're going to access Wikipedia pages, process the information there, and build a list with the Nobel Prize winners per country using the data on Wikipedia. So let's start with these operators. Relational operators are operators like equal, different, greater, smaller, and such. So if you want to compare two values to test if they are equal, you use two equal signs. If they are different, it's an exclamation point followed by an equal sign, and then greater, smaller or equal, greater or equal. You just put these intuitive signs for these operations. You can do these comparisons with numbers. For example, 1 equals 2. If we ask like this, we get the result false. This is one Boolean value when the comparison is false. You can do this with sets. For example, lists. You can compare lists. This is they are compared element-wise. You can do it with strings. They are compared in alphabetical order and so on. So, for example, ABC is smaller than ABD because A is equal to A, B equal to B, but C comes before D. So this is true here. You can do the same with sets. So this one is smaller than that one because it's compared element by element, but then there's an additional element there in this list. You can also chain relational operators. This counts as a conjunction. That means that all the comparisons must be true. For example, 1 less than 4 and 4 is less than 6. So this is true because both comparisons are true. You can do it like this. You can chain different relational operators. So using this, we can obtain these Boolean values, false or true, from these operations, which are comparisons between different values. There are some cases where Python automatically does a conversion before doing the comparison. For example, 10.0 is 10 as a floating point number, so it has decimal places, but just 10 is an integer. It's the integer 10. You can compare the two because Python automatically converts this implicitly and sees if it's equal or not. You can do these kinds of comparisons. But some combinations of types you cannot compare automatically. For example, this is the number 10, an integer. This is a string with the character 1 and the character 0. And if you try to compare the two, you get an error because this comparison is not supported between these two types, integer and string. You can do this manually by specifying how to convert. So we can use, for example, the int function to convert the string into the corresponding integer, in this case 12, and then we can do the comparison with 11. So in some cases you will need to convert manually, but for these most common situations, Python does the conversion implicitly. You can also combine Boolean expressions, that is all these expressions that return true or false. You can combine them with these logical operators, not, or, and. So the negation takes precedence and inverts the truth value, then conjunction, and then disjunction. So they are evaluated in this order. If you are in doubt about the priorities, you can also always use parentheses to make sure it's done in the order that you want. All the relational operators take precedence. So if you have something like one comparison, a logical operator here, and then another comparison, the comparisons are done first, and then this operator is applied. So using these comparisons and these logical operations, you can create arbitrarily complex conditions and arbitrarily complex Boolean expressions that return true or false in order to, depending on values of, for example, your variables. So in all these cases, I'm using constants just to show the idea, but usually we're going to do comparisons where some of the elements are variables because we want to check something about the state of our code, of our program. Other kinds of operations that you can use with that also return true or false and are often useful is the in operator. This returns true if an element belongs into some array. For example, if there is 12 in this array, this would return true. Since there is no 12 inside the list, it returns false. If we ask for 2 in 1, 2, 3, then it's true because it exists there. This works for things like substrings. For example, AB exists in X, ABX because there is an AB there. You can also do all these, apply these logical operators in this case. Note that in the case of negating the in operator, you can write it in a more intuitive manner with not in like this. So this is just a way of making the code look nicer and easier to read. But what this means is the negation of the in operator. So you can do it like this. Another operator that is not generally used, you probably won't be needing it, but sometimes it may be needed if there is a specific case where you need to test this, is the is operator. This tests if you have two references to the same object. And this is good to understand this difference because sometimes it's important, especially when you are dealing with lists or other mutable objects. So if we create an object A with the list 1, 2, 3 and an object B with the list 1, 2, 3, if we ask if A is equal to B, this returns true because Python will compare 1 with 1, 2 with 2, 3 and 3. They are both lists, so they are equal. They are equal lists. However, if you ask if A is B, this is false because this is one list, it's one object in memory, and this is another list that happens to have the same elements, but it's a different object. So A and B are pointing to different locations in memory, and they are storing each, they are referring each to their own object. But when we do something like this, C equal to B, variable C is created as referring to the same object as B. So if you ask B is C, then in this case it's true. C and B are both the same list. This means that if you change the list that is being pointed to by C, for example using append or something like that, then you see the same effect using the variable B, because C and B are pointing to exactly the same object, the same list object. So in some cases you may wish to check if two variables are pointing to the same object or not, or if they are pointing to different objects, especially if you start getting results that are strange. For example, you change some elements of list C and then you are surprised because B also changed, so you can check and see that both of them are pointing to the same object. Okay, so let's use these expressions to specify in our code when some parts of the code must be executed. And let's use as an example solving a quadratic equation. So this is the formula for solving an equation of this form, where we have a quadratic expression equals to 0. A is the coefficient multiplying x squared, B multiplies x, and C is an additional constant. And we have this expression here to find the values of x that make this part equal to 0. So one thing that we can do is we start by computing this discriminant, which is b squared minus 4ac, and check if this the sign of this value. If it's less than 0, then this means there are no real solutions to this equation. If it's greater than 0, then there are two real solutions at this minus b plus the square root of this delta, the discriminant, and minus b minus the square root of the discriminant. Otherwise, if delta is exactly 0, then there is one real solution, which is minus b over 2a, because this part is 0. So to check this, we're going to use this if statement. We're going to branch our code into different branches depending on this condition. So this would be the way we can implement this branching in our code. We create an if statement, if followed by some expression that Python can evaluate, and the colon sign there. So this colon sign we saw with the for loop, with the definition of functions, it's always the beginning of a block of code. The block of code then is specified by the indentation. So this is indented relative to if. It means that this part belongs to if. So if we put a equals 12 and if a greater than 5, we print large. If we execute this, we get large on the console because it's the output of this print. If we put a equals 4 and then execute the same if, we don't get anything as output because since the condition was false, this block of code was not executed. So basically, when we use an if and then a block of code, this block of code can have multiple lines if we want. This part that is inside the if, the block of code inside the if, will not be executed if the condition is false. If the condition is true, then it will be executed. If we can actually use other expressions there than just expressions that return true or false. It's simplest to use expressions that return true or false because it makes the code more intuitive. But for the purposes of if, false is anything that is actually the Boolean value false, none, 0, or empty. Everything else counts as true. So if you do if an empty string print true, this will not print anything because an empty string counts as false. If a string with 2 characters, for example, print true, then you see true output on the console because this counts as true. The same thing with 1 counts as true, 0 counts as false. Something that is empty, like an empty string or an empty list, counts as false. If it has one element, doesn't matter what, then it counts as true. So you can use this for conditions, and I'm just mentioning this so that you know that this is how if works. But in general, it's best to do something like this, something that we can intuitively understand whether it's true or false. We can also branch into 2 alternate branches that are mutually exclusive. So if we need to do something if the condition is true, or something else if the condition is false, then we can use the else block here. So else belongs to the construction of the if statement. You start with if, you have one block of code. This one will be executed if the condition is true. And then you can have else and another block of code that will be executed if the condition is false. So in this case, if x is 10, this branch is executed. So we have x is large output on the console, but this branch is ignored because only one of the branches will be executed. In this case, x is 2, since the condition is x greater than 5 is false, what will be executed is the else branch. The first branch here after the if will be ignored. So this is optional. You can write an if statement just with if and a block of code. In that case, if the condition is false, the code execution simply continues after the if. Or if you want to branch into 2 mutually exclusive branches in a way that one of them is guaranteed to be executed, you can use the if-else construct. In this case, if the condition is true, the first branch is executed, else, otherwise, the second branch is executed. You can also put an arbitrary number of branches by using elif blocks. Elif is a contraction for else if, and this means additional conditions. So the way this works is that Python will test the first condition, the one with if. If the condition is true, it will execute the block inside that condition and then exit the if statement. It will ignore everything else. If the condition is false, it will move on to the next elif and as many elifs as you want, and it will test each of them, and the first one that has a true condition will be executed, and then execution will exit the if statement. If you want, you can also include an else statement, which is the else statement, or the block that follows the else statement will be executed if everything else fails. So if all the conditions fail, the else statement is executed. Both the elif and else statements are optional. You can write if statements without them, so only if you need to do this kind of branching do you use these statements. So for solving the quadratic equation, we have an example of an if statement where we can use an elif and an else. Basically, we receive the a, b, and c, the coefficients for the quadratic curve. We check the delta, we compute the delta and now check the sign of the delta. So if this is less than 0, there are no real solutions, so our solution is an empty list. If it's greater than 0, then there are two real solutions, one here and one over here, and this way we create a list with the two solutions to our quadratic equation. So these are two conditions, if it's less than 0 or more than 0. There is a third possibility, which is if it's exactly 0. In that case, it will fall into the else statement and execute the else block here. So the solution will be just one, a list composed of one element, and the element is minus b over 2a. So this way we guarantee that one of these statements will always be executed, regardless of the value of delta, but only one of these statements will be executed. If delta is less than 0, it will be this one here. If it's greater than 0, it will be this one here. And if neither of these conditions are true, if it's exactly 0, then it will be the else block here. Okay, so this is our function. We create a function. We can add the documentation to explain how it works. We compute the discriminant, and then we have these three branches to generate the solution, and we return the solution we found. Now we should test our function. So we can obtain a solution by calling the solve quadratic function with some coefficients. For example, this would be for 2x squared minus 3x plus 1. And now we have two solutions here, 0.5 and 1. We can test this by plugging in these values into our curve. So for example, to use the first solution we get here, we can do 2 times this value squared, so because this would be the value of x, minus 3 times that value plus 1. So we could do this and check if it's close to 0. It should be, because if this is a root of that curve, it should be close to 0. Then we can do the same thing for the other solution. Remember that in this case we are getting an array, a list with the two solutions. So in general, it's a good idea when you write code to keep these tests handy, and one possible solution for this problem is to create a function for tests where you have, for example, print the solution for this equation, this one here, and then when you call the tests function, you have the result of all these calls to the solve quadratic function. It's also necessary, if you create a function with conditions, to test all the different branches. Because note that if we call the function with this curve, for example, 3x squared plus 2x plus 1, this has no real solutions, so we are only testing this branch here. There was no, Python did not execute this line or this line because it did not get there in the if. So if we only do this first test, we may have errors in parts of our code, and we cannot find those errors because we never reached those parts of the code. So it's a good idea to test with one case where you have no solution, one case where we have two roots, and one case where you only have one root. So this is an example of the if statement. We are going to look at different examples of the if statement, and we're going to use it in quite often in many cases. So don't worry if you didn't memorize everything at once. But the general idea is that you can create branches of your code that are only executed if some conditions are met. And this is important when you think about how to solve problems writing code. Okay, another important thing is to understand how Python manages the names of things, variables, objects, whatever you have, you use, for example, functions, your variables, and so on. So you can think of a namespace as a kind of a dictionary, a phone book, or something like that, where Python is storing names and what they correspond to, what objects, what values are associated with those names. And there are different phone books, different dictionaries with these sets of names at different places in your code. This is to prevent that using the same name in different places creates some collision. We already saw an example of names that exist only inside the namespace of an object. For example, the split method of a string allows us to break the string according to some separators, but we must call it inside the string. So if the string object S is this, A, B, C, D, we cannot just call split with a comma in that case, because Python doesn't know what this split means. There is no entry on this scope, on this namespace for the name split. But if you say that is S dot split, then it's split inside the object S, and now Python knows what this means. This is the method split of string object, and now it returns the value that we want. So this is one example where some function, you could create, for example, a function called split, that it would not collide with the split method in the object because they live in different namespaces. Another thing that we saw was the way functions isolate the code from the rest of the program. And this also happens because the function has its own namespace. However, the function can access the namespace outside the function. So we have this this hierarchy of priorities, which is the local namespace comes first. The local namespace is the namespace of variables that are created inside the function. Then the enclosed namespace, we're going to see this later on, but you can actually create functions inside of functions, and but this is quite a specific use. We are going to skip that for now. Then the global namespace is the one where in the module or in the session where the function is running. And finally, the built-in namespace, which is the set of basic functions and symbols that Python includes. So let's see an example here. We can define this variable var1 I am global in our session in the console, and if we create this function, we can access this var1, because when we ask the function to print var1, it can print I am global, the value of that variable, because it did not find this variable inside the local space of the function, but it can go outside and look up the global namespace and find the variable there. This variable, however, var2, is created inside the function. So this one belongs to the local namespace of the function. The function can also access it. And if we execute the function, remember that the def statement just creates the function object, which in this case is just called function. But calling the name of the object followed by parentheses, it's what causes Python to execute the code in the function. So this is what happens here when I call function parentheses, this gets executed. So first var1 is printed, which is this one that is in the global namespace, and then var2 is printed, which was created inside the function. Now what is the difference between these two? Is that outside the function, I can access var1 because it was created here. It exists in this global namespace, but I cannot access var2. var2 is not defined here. It only existed inside the function. So inside the function, we can access this variable, but once the function terminates, the variable disappears anyway, and we cannot see this name inside the function because Python will only look in this order. If it doesn't find the name in the local namespace, it will go outside all the way to built-in. But if we are in the global namespace and it doesn't find the name, it will look in the built-in symbols. And if it doesn't find it there, then we have this error, name error, because the name is not defined. So Python does not look inside the functions if you're outside the function, but it can look outside the function when you're inside it. This is very useful, having these separate namespaces, because if you have a function called var2, this will now be another global function, a global variable, sorry. So this is a variable named var2. We created with this string, another variable. And now when we call the function, this variable var2, I am local, will be created inside the function, but in the local namespace. So the global namespace has a variable var2. The local namespace inside the function has a different variable that is called var2, but it doesn't matter because it's in a separate space. So this one will not interfere with this one outside, and you can still obtain the value of var2 here, and var2 will not change just because the function happens to have a variable with the same name. So this is very important because it is essential to make sure that once you test the function and the function is working, you can use it in your program without fear that it will break everything that you have in your program by having some collision with a variable name or something like that. So remember the order by which Python looks at the names of objects that are being referred to, and this means that the function will not break things that are running outside the function unless you deliberately make it so that the function does some side effects or something like that. But in general, you will have this protection in place. Okay, so one thing that we need to do sometimes is to bring names from different namespaces into our own. And this is especially the case between modules. So the global namespace here is either inside the session that you have running or inside a Python file. The Python file, the .py file, is a Python module. Sometimes you may want to bring functions or other kinds of objects that you created in different modules. In that case, you can use this import statement to bring into your own namespace the names that are defined in other modules, in other Python files. So suppose that we created this function here for the quadratic equation, and we saved this code. So this is our source code file. We saved this in our working folder with the name quadratic.py. So this will be a module that contains the definition of the solve quadratic function. If we want to use that function, we can do import quadratic. So this will run this module and bring the name quadratic into our own namespace. So the name of the module now exists in our namespace. This means that we can say, tell Python to execute the function solve quadratic that belongs to the quadratic module. So we can do this, we import the module and we say quadratic dot solve quadratic with the parameters that we want, with the arguments that we want. So when we import the module, the module will be an object too, and this object will have its own functions and other objects that we defined inside the module. Another way, we can do this other ways, but in this particular way, note that we import the name of the module, but not the name of the function on its own. So we cannot just use solve quadratic. Python doesn't know what this means, but we can tell Python that inside the quadratic namespace there is a solve quadratic function, use that one. So this is what we did when we imported the name of the module. We just have access to the module itself, and now we can tell Python to use whatever exists inside the module. We can alternatively do this from the module quadratic. Remember, quadratic is the name of the file where we have the function defined. We can import one particular object, in this case solve quadratic. So what this does is Python will run the quadratic module. It will define this object, this function, and then we will import the name of the function into our own namespace. So now this is like what would happen if we had defined the function in the namespace we are working. So we can use now the function with the name solve quadratic, and it works. We can also import these names changing the name, giving an alias. So if we do import quadratic as QD, now we can use QD instead of quadratic and say, for example, qd.solveQuadratic. This is useful if you need to avoid collisions with names that you already have. So you can give a nickname, an alternative name to some of these objects. Or if you don't want to write too much. So if you have a module that has a large name, but you want to just simplify writing, you can do it like this. So this makes it very easy to reuse your code. You can write code into modules, and then if you need something from those modules that you already wrote, you can just go and fetch whatever functions or other objects that you need into the new code that you're writing and keep on using them. So you should bear in mind this advantage when writing your own code, because it pays off to try to decompose the problems into smaller pieces that are useful in general for other applications, because then you can easily reuse them whenever you need to do this kind of thing. So in this case, if we needed to solve a quadratic equation in a different context, we would just import it and use that to solve our problem. So let's see, apply this to our example of computing the pH of a solution. So we saw this last week. We computed the pH of this benzoic acid solution. We are solving this quadratic equation. So you have this expression here. We have to use the formula for solving the quadratic equations. And we also had to compute the logarithm of base 10 of the concentration of these hydrogen ions. And we were doing that approximation to the logarithm and so on. But there is a log10 function in the NumPy library, and we have written a function for solving the quadratic equation. So instead of doing everything again by ourselves, we can greatly simplify the task of solving of computing the pH of the solution by importing from the NumPy module this log10 function. So NumPy is a standard library for processing numerical data. We'll see more on this next week. And you have this installed with Anaconda. So Python knows where this library is, so you can easily import it. And we're going to import just the log10 function. We don't need the whole NumPy library, so we'll import that one. If you have the quadratic file in the same folder as you have this source code, then Python can also find it easily because it looks on the same folder where you're working. So now from our own quadratic library, we're going to import the solve quadratic. So from this module, we're going to import the solve quadratic function. And now to compute pH, we just get the roots of the quadratic equation by calling the solve quadratic function with the appropriate argument. So 1 for x squared, Ka for the x term, and minus Ka multiplied by the initial concentration for the constant. This will return a list with the roots. And now we want the maximum value in that list, because we don't want the negative root, we just want the largest one, because that's the one that is physically meaningful in this case. And we return minus the logarithm base 10 of this hydrogen ion concentration. So you see, basically we have 2 or 3 lines of code to solve everything, because we are reusing code from other modules. You can also document your module. So for example, in this case, we have this string here in the beginning, And this works similarly to the documentation on the list. So if someone, let's say we save this file as phcalc, so this would be our module. If someone imports the module phcalc and asks for help, they can see the string, the documentation string that we created here. It's a module for pH calculation, and then it has some indications on how to use the module. So this is useful if you are writing code that either you want to use later on in case you forget how to use it, or if you want to give it to other users. It's easy to import a module, type help, and see what documentation there is available. So typically this documentation explains what the module is for, gives some examples of the main functions, and so on. So you can include in your code these hints for how to use it. It's also a good idea to have this inside your code, because it makes it easier to understand what the code is for and what the functions are doing. So it has this twofold role of helping you when you read the code and helping any user when they try to use the code. Okay, one thing to remember is that when you type the import, or when you execute this import statement, Python has to run the module. So it does the same as if you were doing F5, for example, and running the complete code. It has to do this because only when Python executes the code are those objects created, for example, functions, classes, and so on. So if you want your model to be imported by other modules, avoid having unnecessary code that gets run automatically. So for example, if you have tests for your functions, you can put them in a test function so that only if the test function is called are those tests actually executed. Otherwise, the tests are not executed. Okay, so let's see a more practical example of using modules and conditions and processing remote data. So we have in Wikipedia these pages with the lists of Nobel laureates. So these are for chemistry. They are in this URL here, and we have these tables which has the name, the people who won the award that year for each country, and so forth. So one thing that we're going to do is to count how many Nobel laureates there are per country in this table. So we're going to organize the data counting the number of Nobel Prize winners for each country. If you look at the source of the HTML file, you'll see that, in case you don't know, HTML files are text files that have these special tags that the browser interprets. So there's a lot of things here before, but then this particular table is a table of this class, wiki table sortable, and then we have these tr tags are the rows of the table, the th are the header cells, the td are the normal cells on the table, and so on. So this is a text file. It's a bit confusing if you're not used to looking at it, but it's basically text. It's a string. So we can parse this string, decompose the string, and look for the parts that we are interested in. Specifically, we have these cells, they start with TD, that have this flag icon class, and then which correspond to these cells here that have the flag, and then they have the name of the country. So we can find these cells between the TD and the /TD tags. So each of these tags marks the beginning of an element in HTML. In this case, it's a cell from the table. And then they have the corresponding end of the element by using this / and the same tag. So this would be a cell containing 1901. This would be a cell containing all this text and so forth. So we're going to find the cells that start with this text, span class flag icon. And then we're going to break this down by all these tags until we find the name of the country. So basically, if we cut this part of the text using these greater than marks, we find this on after 4 of these. So on the 5th block, we find the name of the country. We're going to see better ways of parsing HTML using libraries and so on, but this is just to give you an example of how you can do this with basic Python and to exercise a bit this part of processing strings, because it is often the case that you need to extract some information from strings. So this is what we're going to do. We're going to start by planning our program. We're going to get the page from Wikipedia, so the HTML source. We're going to extract all countries for the list of Nobel Prize winners, but some countries will come many times, so several times, because there were several people from those countries winning Nobel Prizes in different years. So from that, we're going to get a list of the different countries. We're going to sort it alphabetically, and then we're going to count how many times each country occurred and print everything on the console. So this will be the general approach. We're going to follow this algorithm to solve this problem. First, we're going to see how we can get data from Wikipedia. This is easy to do with the requests module. So if you import the requests module, you have this get function on requests that receives as argument a URL. In this case, note that I truncated the URL. The complete link is here, but if I put everything, then I don't have space in the slide. So there's something missing here, but this is the idea. You put a link, a URL here, and the get function returns an object that has the result of your request. So there are different attributes in this result. For example, it has an OK attribute that is true if everything went fine, or false if there was some error getting the data. There is a status code. You can find there, for example, the 404 if the page was not found, or 503 if the server was busy, or things like that. If it's a 200, then everything went fine. And then you have this text attribute that gives you the source code of the page, so the text of the HTML page. And this is what we need for this example. We need the text of the source code of the HTML page to extract the names of the countries. So let's create a function that gets the data from Wikipedia, or receives this data from Wikipedia, and breaks down everything into the individual countries. So this all countries function will receive the text of the HTML page. It's going to find the part where the table starts. So if we split the text of the HTML page by this header of the table, we will have our page broken into two parts. Everything that comes before the table, and then the table and everything else. So now we ask for the second element of this list after the split, which gives us everything at the beginning of the table onwards. Now we're going to split again whatever remains by the end of the table and get only the first block. So what we're doing is extracting only the table. We are going to retain from the text everything after this string, and everything, once we do that, everything until this string. So this one is the part of index 0 of the split. This one is part index 1 of the split. Now we're going to break everything down into cells. So this TD tag indicates the beginning of each cell. And we're going to run through all these cells and pick out the ones that start with the flag icon class. So these are the cells that have this icon with the flag and the name of the country. So basically we broke things here to get this part. We retained everything up to the end of the table, so we retain only this block. Now we split into these cells. Every cell becomes a different part, and now we loop through the cells and search for the ones that have what we want. Once we find these cells, we split again by this greater than sign here, so that we can pinpoint the name of the country there in the fifth block after splitting. We split again by the smaller than here, so that we clean this part and we retain only the name of the country. So this is one example of how you can break down the strings and extract the information that you want. In this case, this function is not yet getting the information from the internet, but it's just parsing the source code once we already have the source code there. So we can test this. We're going to use the requests get to get the page from Wikipedia. And then we're going to call the all countries function using the text that we got in the response. So this text attribute of our response is the source code of the page. And now we see the result here. We have Netherlands, Germany, Sweden, and it's a good idea to take a look at the page to see if we actually are getting the correct names, because if you make a mistake, maybe you're skipping the first one or you're not finding some of them and so on. So when you test your functions, don't just check if you have some result, also check if the result is correct, because it's important then when you're going to use the function to make sure you get the right answer. So you see there are some countries here like Germany that appear several times, and now we're going to have to count how many times they appear. So we want first to have a list of all the different countries in alphabetical order. This will be the basis for what we want to count. And this is actually very simple to do if you know how to use sets in Python. So there is an object called set that you can convert the list to set and then back again. It can also be done easily with list comprehension, this kind of condition. But since we are using only the basics of Python and what we saw so far, I'm going to write this down with several lines of code. But in general, in Python, you often have this situation where if you know more Python, you can write more concise code and more easily. But even if you don't know that much Python, you can still solve your problem with a bit more code, a bit more steps, using more elemental parts of Python. So what we're going to do here is we're going to start with an empty list with all the unique countries. We're going to iterate through all the countries. So C will first be Netherlands, then Germany, then Sweden, and so on. So C is going through all the countries. And we're going to check if C is not present in this list of unique countries. If it's not, then we're going to append to the list. So we're going to add the country at the end of the list. But if it is in the unique list, then the not in will return a false, and this code will not be executed. So that country will be ignored and the loop will continue on the next country. This also illustrates how you can nest blocks of code inside one another. So this is the for loop. Inside the for loop, there is an if statement, and inside the if, there is this append call here. So after we finish the loop, we have in this unique list countries appearing only one time, because if a country is already there, it's no longer inserted into the list with this append. So now we want them in alphabetical order. We can just call the sort method of the list. So lists have a sort method that you can use to sort everything in ascending order, as long as all the elements of the list can be compared. So you have to be careful. If you have mixed type of elements, this can return an error. But in this case, we only have strings, so they are sorted in ascending order. This means alphabetically. And now we return the list unique, and we have here the names of the countries, but only one country once each time, and in alphabetical order from Argentina to Yugoslavia. So now we want to count how many we have of each country. Well, actually, we can generalize this, and this may be useful not only for countries, but for some general application. And what we want is count how many times these values occur in each of these categories. So we're going to start by creating a list of counters that has as many counters as the categories we have. In this particular case, the categories will be the unique countries in alphabetical order, so these, and the values will be the full list of countries. And what we want to do is run through this full list and check how many, and keep counting for each category how many times the countries appear. So one easy way of creating a list of zeros is just to create a list of 1 0 and then multiply by how many zeros you want. So in this case, we want as many as the categories we have, and this creates a list with as many zeros as there are categories. And now for each value, so for each country in the full list that has all the repetitions, we're going to find which category it belongs to. So we're going to ask in the categories list, what is the index of that country? What is the position of that country in the list? And then we're going to increase the counter corresponding to that position. So if we find Argentina, for example, Argentina is the first country here, and so the index will return a 0, and we're going to increase the counter at position 0. If we find, for example, Belgium, we have this in the 4th position, index will return a 3, and we'll increase the counter at index 3, and so on. So at the end we return the counts, and this will be a list with the same ordering as our unique countries, and with the number of Nobel Prize winners for each country. Okay, so now we can wrap this up into a single function that gets the data from the URL, checks if everything went well, and if everything went well, it counts the Nobel Prize winners per country and returns a list of strings with our table, or a string with our table. Okay, so let's look at this in different parts. First, the name of the function and the parameter that receives the argument we need. We want to make this general, not only for chemistry, but for different Nobel Prizes, so we receive the URL here. We start by requesting, by getting this page from the internet and checking if everything went well. So if it's not okay in the response here, we just exit from the function and with an error. We had an error getting data. So we return this string. Note that when the return is executed, nothing else is executed because execution exits the function. So this is one way of exiting the function if something went wrong. If everything is all right, then not ROK is false because ROK is true. And so this return is not executed, it's ignored, and execution will move on to this part. So we get all the countries, the complete list of the countries. We get the names in alphabetical order, only the unique names in the countries. We count how many times each country appears in those names. And now we're going to build the table. We start with an empty string, and for each of these names of the unique countries, we're going to add to our string the name of the country, then a tab character. So to do this table here, we use this \t. Then we add the count of how many times this country occurred. But since we are concatenating the string, we need to convert that into a string so that we can put it into the same string, and then changing the line, so a new line character. This is a special character that inserts a line break. So when we print the string, we have a line break there, and it changes the line to the second line, and so on. And now we return this string with our table. We could do a print inside the function, but this is often something that you should avoid. You can write a function specifically for printing, but you should always have a version of the function that does not have print, so that you can use it either when you want to print the result or when you want to do something else with the result. For example, save it to a file, store it in a list, something like that. So if the function does not have a print, it's easy to get the result of the function and then print it. You just need one extra line of code. But if the function has the print here, so if this had, for example, a print table, every time you use the function, you would see the table appear on the console, even if you didn't want to. And there would be nothing you could do to prevent that. apart from going into the function and deleting this line because it's bothering you. So remember, separate the parts of your code that deal with the interface, with inputs and outputs and so on. Usually do that separately so that you have more control over your functions. You could also do this with the requests. For example, you could do this separate from the function if you thought it would be useful without fetching the data from the internet. Okay, so now that we have this, and we have this generic function, we can look at the results from other Nobel Prizes. For example, physics, we get the same kind of result. We can do medicine, literature, and so on. So we have here the lists for the different Nobel Prizes, and all we need to do is change the URL we feed into the function, because since Wikipedia has everything in the same format, we can get this easily from all these different pages. Okay, so before we go to the break, just to sum up, we saw how to create and use Boolean expressions. So Boolean expressions are those that return true or false, and we generally use them with the if statement to create conditional branches in our code. So the if statement can include it must include at least one condition. It can include several conditions, and optionally also an else statement, which allows you to put a branch that is executed if every other branch fails. We also saw how to import objects from other modules, either from the libraries you have installed, for example, requests and NumPy, and we're going to start looking at more libraries in the future, because now we're going to start focusing on these tools to help you process your data. But you can also import objects from modules inside the same folder, which often will be modules that you yourselves created. So think about this when you're organizing your code, because you can easily reuse code that you wrote before. And we saw an example of using data from Wikipedia with the requests library. Okay, so for this part, I recommend, of course, chapter 3 of the lecture note, and this chapter 5 until 5.7 of Thinking Python. You have also some other things on chapter 10, or if you want, you can read the documentation on the requests module, but this is mostly if you're actually interested in getting data from the internet as part of your work. Otherwise, you can just leave that for now, because it's not important to know much about the requests module to move forward. Okay, so let's take a few minutes break. We'll continue at 5 minutes past 6. See you soon.